Didn't see you there. Welcome to my class on the main sequence. So, as you can see, this is the main sequence. It involves all the obegamophens, and that's all the spectral types, but we'll get into that later. So as you can see, it goes from 10 to the power of 6 all the way down to 10 to the negative 4 at 2,500 degrees Kelvin. Now that's hot, but it's not bright. So we have the O, the B's, the A's, the F, the G's, the K's, and the M's. And that's it, guys.
Hi, I'm Stephen Lee. Now, you might be wondering, what are the star fuel source? Main sequence stars are categorized by the source of their energy. They are all undergoing fusion of hydrogen into helium within their core. The rate at which they do this and the amount of fuel available depends on the mass of the star. Next question is, what are the size ranges? About 90% of the stars in the universe, including the Sun, are main sequence stars. These stars can range from about a tenth of the mass of the Sun to up to 200 times as massive. What are the main components of the star? The majority of these stars are described as being main sequence, which means their core are fusing hydrogen to create helium. Thank you. Stephen Lee. And Michael.
Why do you have to put that in?
Hello everyone, my name is Natalie, and today we're going to be talking about main sequence stars. So, one question is, how long does the lifetime of a main sequence star last? And the Sun, which is a main sequence star, it has a lifetime of 10 billion years, and it's currently 5 billion years old. So it's like halfway through its main sequence lifetime. And some other stuff about main sequence stars. So basically how long they live depends on how big it is. So a higher mass star may have more material, but it burns through it faster due to higher core temperatures. And while the Sun will spend about 10 billion years on the main sequence, a star 10 times as massive will stick around for only 20 million years. And a red dwarf, which is half as massive as our Sun, can last 80 to 100 billion years, which is way longer than the age of the universe. So that's one reason red dwarfs are good sources for planets hosting life. And main sequence stars are also called dwarf stars, and they fuse hydrogen in their cores, and they are smaller than giant stars, but not necessarily less luminous. And main sequence stars belong in the luminosity class B. So that's all I have.
An emission spectrum is simply a chart or a graph that shows the intensity of light being emitted over a range of energies. Depending on the type of elements that a star is made up of, the color will vary, as the color that the star is helps identify the elements it's made up of, which is basically what the emission spectrum is for. This is the emission spectrum for the Vega star, and the average surface gravity of a main sequence star varies from one another, as there is a big range of sizes of the stars. A star's surface gravity depends on its mass. The smallest the main sequence star can be would be 0.08 of the Sun's mass. The main sequence average temperature is between the range of 7,500 to 10,000 Kelvin, with their luminosity range being between 8.8 through 24.